Hey everybody, hope you guys had a great weekend. Just got word the other day that the governor said that schools will be closed for the rest of the school year. So, lucky for you guys, you don't have to see my ugly face for the rest of the school year, but you will have to listen to my annoying voice. So, today's lesson is hyperbolas. Hyperbolas. So we've done ellipses, we've done circles, and now this is the third conic section we're going to do, hyperbolas. Here's two different equations for a hyperbola. This is a hyperbola that opens left and right. So these arcs right here, they're actually called branches. These are actually the graph of the hyperbola. So a hyperbola consists of two separate arcs or separate branches. Right? There's a center right here, the center, which is the center of the two, or in the middle between the two hyperbolas. These endpoints of these arcs or branches are called the vertices of the hyperbola. And again, the hyperbola consists of these two branches. And here is the equation for hyperbola. X squared over a squared minus y squared over b squared is equal to 1. When it looks like this, this center is 0, 0. When it looks like this, the center is HK. So this center point would be HK when it looks like this. This A is the distance, just like an ellipsis, A is the distance from the center to the vertex. So from here to here or from here to here is a distance of A units, this A right here. Now in ellipses, A was always the larger number. That's not the case here. Here, A is always under the first fraction. So A squared is under the first fraction, so the square root of A squared would be A. Now, the other part of the hyperbola, that you need to know, besides you'll need to know the center, you'll need to know these two vertices, you'll also need to know these imaginary dashed lines that go through the center. These are called the asymptotes of the hyperbola. So these curves hug these asymptotes on all four of these sides here. So you'll need to know the equation of these asymptotes. So they're just lines. So these are just writing equations of lines. When the center is 0, 0, because the asymptotes pass through the center. So when the center is 0, 0, these are the equations of these asymptotes. Y equals plus or minus b over a x. So b over a is the slope of the asymptotes. But this would be the equation because the y-intercept would be 0 because it passes through the origin. But the slope of these asymptotes, this one has positive slope, so this one has slope positive b over a. This one has slope negative b over a. That's why it's plus and minus. There's actually two asymptotes, one with positive slope, one with negative slope. If the center is not the origin, then this is how you write the equation of the asymptotes. You just plug in the center into h and k, and the slope is the same, plus positive b over a and negative b over a. So the slopes are b over a if the hyperbola opens left and right. When the x is first, when it's x minus y, the branches open left and right. However, some hyperbolas open up and down like this. They open up and down when the y is first. So again, when the x is first, they open left and right, but when the y is first, when it's y minus x, the hyperbola actually opens up and down. Again, A is always on the left. Again, here the center is 0, 0. Here the center is HK. A, again, is still the distance from the center to the vertex, just like in the one above. So from this center to these two vertices is the distance of A. From here to here is A, from here to here is A units. Now the only thing that's different now when it opens up and down is the slope of the asymptotes is A over B, positive A over B and negative A over B. So when it opens up and down, the slope is A over B. When it opens left and right, the slope is B over A. All right, so that's the only difference. That's the only difference from opening left and right to up and down is the slope. Again, left and right, the slope is b over a. When it opens up and down, the slope is a over b. Positive a over b, and that one's negative a over b. All right. Again, the center is hk over here. H always goes with the x, and k always goes with the y. Don't get that confused. Over here, again, h goes with the x, k goes with the y. All right, so this paper right here is all the background information that you're going to need to know for hyperbolas. I'm going to stop the video now, and I'm going to do 3 examples. All right, so again, this is all the information. I'm going to actually send this to you guys on Google Classroom so you have this sheet handy.